basically, if the other one was simplified formula, molecular formula is something known, or we call it the true formula. Okay? So the actual thing. So that would be like our glucose, right? So C6H12O6. That is the actual formula. All right? Okay, so we can use our percent composition to find that ratio, and then we can use properties and other pieces of information to now get that actual molecular formula. All right? As well, like we can be using the mass of whatever sample we're looking at and kind of put it that way. All right. So looking here, this is your key point. The relationship between molecular formula and empirical formula can be described as X times empirical formula gives me my molecular formula. What do I mean by that? These are technically the two steps, right? So we're going to divide our experimental mass by the empirical formula's mass. And you can use AMU. The answer you get is your X value. This X value is a ratio. All right, so this X value ratio. All right, once we get that ratio, we can multiply all of the subscripts in the empirical formula by that. So to simplify that a little bit further, what your steps are is you're going to take your molecular formula mass, which is usually given. You're going to divide that by your empirical formula mass. Yeah, you have to find your empirical formula mass usually. Okay? When you divide those two, that's going to give you a ratio. Once you have that ratio, then you're going to take your ratio. So this is step 1. Step 2 is you're going to take your ratio and you're going to multiply it by everything in your empirical formula for their subscripts. So what that means is that this is going to be a whole number. If you get a decimal, then something is wrong, either the number that was given to you or what you're finding for your empirical formula mass. All right? You have to be ending with some sort of a whole number ratio on that one. So the example that they gave you was one where it's diborane, and they give you this 27.67. That's your molecular formula mass, right? And the empirical formula was this. So we have to find our empirical formula mass, which is the step that they're showing you right there. So that's your empirical formula mass. They divide those two to get this number. That's your ratio. And now that gets distributed to your different subscripts. And that's how you get your molecular formula. All right? So it's not too bad. Okay? So the example that we have down here, empirical formula is P2O5. Perfect. Experimentation shows that the formula mass of this compound is 283.89. That's your molecular formula mass. So we're going to go ahead and put molecular formula mass divided by empirical formula. So 283.89 divided by, and then we had to find our empirical formula mass. So if it's P2O5, then we're going to have phosphorus. There's 2 of them. So we'll multiply 2 by its molar mass. And for oxygen, we have 5 of them. So we would get the answers of typing those in, 61.948 for phosphorus and 79.995 for oxygen. So add those together to get our total empirical formula mass, which would be 141.943 grams. So now we have this, and that's what we can put in down here. Okay, so we're going to put our 141.943 We're going to plug that into our calculator. We're going to divide them. We're going to see that it's 2.000000, and I think there's like an 8 over here or something like that, which means this is approximately the number 2, right? That's my ratio. So that means that if I have P2O5, I'm going to multiply everything by 2. Okay? So P4O10. So that's empirical and molecular formulas. Okay? There will be an assignment that goes over these, so just make sure you're ready to do that. If you have any questions about your lab, you can still come ask me. Otherwise, you should be turning those in tomorrow. Okay?